Okay, let's take a look at this problem. I actually started it, but I kind of failed with the video. Well, the longest string chain, you are given your words, and there's a predecessor, means that word A is predecessor of B if and only if you can insert exactly one in any position without changing the order. So ABC, AB, AC, like here AB and C, order does not change. Here it changes, so it is not a predecessor. And so here return length of longest possible word chain with words. So my initial idea thought was to sort it. So for that, like we could but sort it based on their lengths. And when we do that, we simply like predecessor is just minus one length of it. So we are making sure that we keep the order of predecessor link chain so that we can run 2 for loops, and it's much easier to go over the data like inputs. And for that, like I thought about doing it like this. We sort it with key, lambda, and length of x. And if we print it, we will have words like this. Let's see. So as you see there, let's give another example here. Let's give this. It should be xb xbc, right? Okay, let's work like that. So now I need a function to understand if something is predecessor of another thing. So and then after when we'll be using those to explain the algorithm because I explained it in the previous video. I forgot to explain it here. So we will have this, and then we take xb, and then we will say it in dictionary probably, and then later on, or like we check if this is predecessor of the next one. If it is, we will just put it in an array. Let's see, and then same thing here. But as you see, like we might have something if we have something like A, in that case we will have A in between here in these two. I'll show you this two, and because of that I have to save this xbc in a dictionary, and then when I'm here we'll check if, so how do I check? Maybe, yeah, when we sort it we have n log n, right? This is n log n. So n log n. And if you run 2 for loops, then it will be n squared. There is also an easier way to do this, in which I'll be using hash table. But for now, let's do it with 2 for loops. and we will just go over it for XP. I'll go from left to right, and every time I will check it with the predecessor, if it is predecessor. But for that, let's create that is predecessor, and we'll pass word 1 and word 2, and we just check. How do we check if their length is just -1? We just return it if length was 1 is -1 equal to length of word 2. We continue, else return false. And here we check for every for we have to count similarities, like same count with 0 for every I in range word 2. Let's see. For every index in the word 2, not word 2, then word 2, not word 1. This is the shorter one, but I will need the length here. So for every one, like if words 1 I is equal to words 2 I, I need I and J. Yeah, for every word 2. Okay, if I okay, let's say that we have XB and XBC, okay? And then when we pass XB, it is fine here. It fits with this. And then we come here, we have 3, length 3 here. We go in, it is not equal to that. We go here, if they're equal, means that I will just increase the same count by 1. And if they're not equal, I just increase the I by 1, or I don't do anything. And I increase I by 1. First is they are equal, and the second one they are equal, and in the third one, or the second one, just return false. But here if same count is equal to length of word 1, return true. True. So we go in, this is not equal to that, we come here, same count is just 1. Now, then it is 2, which is equal to true, then we just return true. If we had like C in the beginning, then of this one, then we will just go here, they're not equal, and they're not equal, else I just don't do anything, which means that I increase I. When I increase I, we check ij. Maybe I need a j. J is less than 2 if word 1 y is equal to word j, then we just increase y plus 1, j plus 1. Else this is for sure this will happen, and so if y is equal to word return true. Let's call this xp c. Let's see. This should return true. This should not return true. This should not return true. This should return true. Not true. Okay. It's working. Now for every I in range words, and for every j in range from I to length again words. So for this, for XP, we just go from start to end, and if words I, words j is predecessor, in that case, we just increase the I need the DP array, which is in the length of words. DPI will be equal to, it means that it should return 1, yeah, it should be plus 1. Should we hold the maximum? Here, longest string 0. Expected 5, and just go over it, dp plus 1, until length words, length words, then ij, c, xp, this should be class 1, and then those, this should true. Maybe okay, so maybe add this API console. No, dpj will be dp plus 1. So this should return 1. maybe they should start with 1. And I don't have to return this. Let's see. I think the complexity is not that good here because we have this, which is weird. Expected 4, we got that. For A, we have A, B, A, B, C, A, B, A, B, A, B, D, A, B, D, D. For A, I just go A, B, C. Let's see. Yeah, 1 here. No, it is 2. This is 2. B there is empty. The other ones are 0. Let's start. And then I come here. I have A, B, same. This is just 2 now. A, B, D, this is 2. This is false. I come to this. I come here. A, C. This is predecessor. And then from AC to ABC. And then this predecessor. AC. Okay, my algorithm should be 3, right? But I don't want that. Or do I want that? No, I don't want that. This is 3, I come to BD, I come here, I make this 1. That's the problem. I guess, and DPJ plus 1 should be greater than DPI should be greater than DPJ. Let's see. Okay. So here this is just n for every n you go n minus 1, which means of n squared. So we don't care about sorting because it is n log n. So overall time complexity of this answer would be of n squared The space is just off. We're sorting maybe n again. Or n. Merge sort space complexity. It's off n. Okay. Off n because when we're sorting, we're using team sort or not team sort, space complexity. Off n. Okay. So and again, and we have that here. So it is just off and because of sort and also DP here. So maybe it is not a tool solution, but it's a pretty good solution because it's kind of like a like if you don't sort it, it's kind of hard because you have to use too much space. Let's think about that. Let's say that if there's improvement, like we want best time, in that case, maybe we could, instead of like sorting, we could maybe save some answers in dictionary and then we check it. So here we're trying to sort it because we want every predecessor should be before the next element, and we can ensure that, or like we can use hash table to go over those, search for those, so which will take a constant time, but for that we need to of n, like it will be much complicated algorithm and we would need of an additional space maybe, but that would be still of n, so I think that would be a better solution. But we will in that case have to search for every possible predecessor, which means that we'll have to delete one character from each, then which will in the end will give us n times k, and here also n times k. So I think this is much better than that because k might be, yeah, if you want better k time, then maybe we could do that. But now for now, yeah, I don't have any additional thing to say, so this is my answer to longest string chain.